Hi everyone. In this video lecture, let us discuss about one-dimensional heat conduction along with phase change. Here I have taken 0.01 meter ice rod with the initial temperature of minus 20 degrees Celsius. After time equals 0, the right hand side will be exposed to the new T-hard temperature, that is 80 degrees Celsius. The other end, that is left hand side, will be insulated. And the property of ice and the water at two different temperatures are provided here. Now let us solve this problem in console. Since it is a one-dimensional problem, let us click on model wizard, select one-dimensional, click or expand heat transfer, click on heat transfer in fluids, add, click on study. Since we are going to solve a dynamic study, let us select time dependent study. Click on done. Now let us define global parameters. I have already saved the parameters in already pre-existing text file. You can type the file manually as well. Click on parameters, click on load files, and you can select this file. You can manually give the input as I given here. T transition temperature, at what temperature the fusion happens, dt, the transition interval, Lm is the latent heat of the fusion, T naught initial temperature, T hot, the heat T hot temperature, density of ice is given here, density of water here, and density of ratio is given here. Since the problem need to be converted into material coordinate from the spatial coordinate, I'm going to use rho ratio to convert from spatial coordinate to the material coordinate. Since after time equal to 0, the right hand side will be exposed to the temperature of 80 degrees Celsius after time equals 0. I'm going to create step function. For that, click on definition, more functions, step function. Let me name them as, let me name it as uh, T right. And when time equal to 0.05, let me take approximately, I'm going to use step right in the temperature from T naught to T hot. Now we define the step function. Now let us create a geometry. Click on geometry, or you can click it here as well. Interval. The width will be 0.01 meter. Build all objects. Under interval, we have form union. Click on that and select the object and build all. I'm just connecting both the points to make it as a ice cube. Then click on material here. Or before selecting the materials, let us plot the step function. Click on plot, and you can observe here the transition in the temperature from T naught to T hot happened at time of 0.05 seconds. Now let us define materials. Click on material, click here as well if you want, and click blank material. Let me type it is a ice. Let me replace it as ice. Drag down. Heat capacity is given in our it is given in our problem statement, that is 8052, and the default unit of console is joule per kg Kelvin. That's what given in the problem statement as well. Then density of ice cube is 918 kg per meter cube. It also predefined in our parameter, that is rho ice. Thermal conductivity, it is 2.31 watt per meter Kelvin. The unit also same as what prescribed by the console. Now again click on blank material. Now let us rename it as water. Select material, drag down, heat capacity is 2052 joule per kg Kelvin, and here density, we need to convert density into the material coordinate. For that we need to multiply by rho ratio. So Rho water multiplied by RHO ratio, which was defined previously. Similarly, we need to convert thermal conductivity as well as in the material coordinate. We need to do same thing. The specific heat, sorry, thermal conductivity is 2.31. Sorry, we have to take water 0.613 multiplied by rho ratio. Now we have successfully defined our both material. Now click on heat transfer fluid. Click on fluid. Since here phase change involved here, let me click on physics, attributes, select phase change material. By default in console, the transition temperature is given 273.15 Kelvin. We don't need to change the transition interval. Already we define as dt, and latent heat we define as Lm. So we successfully given the attributes here. In our study, what I'm doing here is first I'm going to run the program, run the console with latent heat. Next I'm going to run it with without latent heat. After that, I'm going to give different dt value here, and I'm going to study what is the temperature profile along the x coordinates. Now let us define initial values. It is T naught, and we need to select boundary 2. For that, click on boundaries, select temperature. Here, after time equal to 0, the right hand side will be suddenly exposed to the new temperature. For that, I'm going to write step function, which we already defined. T right, it is a function of time, and since we are giving the frequency of change in temperature, let me put 1 by second as the unit. Close it. Now we define the T naught as well. Then by default, the left hand side is insulated. Now click on miss here or here, select edge. Then right click on edge, select distribution, and under number of elements, put it as 120 and build all. Now let us select time dependent. Here I want to capture the results at different time duration. For the click on range, start from 0 to every 15 seconds, then stop at 60 seconds. Then click on replace. Again, I want to add another range. Click on range. Now I want to capture from second minute, that is 120 seconds for every 60 seconds till 20 minutes, that is 1200 seconds. Click on add. Then I'm going to modify my tolerance value manually. Click on user control and define it as 1 e power minus 3. Now click on compute. This is our temperature profile. Let us change the unit into degree Celsius. Expand temperature, line graph, and here select temperature in degree Celsius and click on plot. Here, what we can observe here is there is a sudden dip in temperature at 0 degrees Celsius. You can see here almost the temperature remain constant here at different time. And if you want, you can add, we can display the legends as well as drag down. And here, so legends, since it covers our image, I'm just removing this click. Now, let us run this experiment without latent heat. For that, click on physics, art physics, sorry, add study, click on time dependent, art study. Now, our second time dependent study is created. Now, similar to the previous study, click on range, 0. For every 15 seconds, we need to select 15 till 60 seconds. Replace. Again, click on range from second minute, that is 120 seconds. For every 60 seconds till 20 minutes. Add. Expand study extension. Click on auxiliary sweep. Click on add. Here, select latent heat of fusion and put it as 0. Now, let us modify the tolerance value as well as user control 1 e power minus 3. Click on compute. This is the temperature profile along the x coordinate, and a clear difference we can observe here is there is no sudden dip in the temperature along the x coordinate. The temperature drops gradually. That is effect of excluding latent heat. We know that latent heat is only contributes to the phase change. During that, there is no temperature change. When I'm going to give latent heat as 0, here that's what happens. All the heat will be utilized for the temperature drop or rise. Let us change the temperature in degrees Celsius. So we can observe here at the 0 degrees Celsius, there is no much sudden drop in the temperature. It gradually decreases. Now let us implement the different experiment with different DT values. For that, again click on time dependent, hard study, under study, click parametric sweep, click on add. Now I'm going to change, I'm going to give different DT value 0.5, space 1 and 2. Then click on time dependent. As usual, click on range, starting from 0 for every 15 seconds till 60 seconds. Replace, click on range again. Now, starting from second minute, that is 120 second, every 60 second, I want to capture till 20 minutes. Add. Yeah, that is the result. It combines both different DT as well as the different time. Now let us choose only the specific things here. Expand temperature, line graph, and the data set. Let us select parametric solution. Yeah, param, from the parameter selection, select only first time selection. Let us select only few from the list. Let me select 30, sorry, 30, control 30, 60, and 300. And click on plot. So here I have taken only first one, that is dt equal to 0.5, and we can observe there is sudden drop as the temperature remains 0 at 0 degrees Celsius. Let us change the temperature in degrees Celsius so that we can clearly observe here. Click on plot, and we can observe here at 0 degrees Celsius the temperature line almost flat. Now let us duplicate this plot. Now come to the data set again, and let us change this value from the list. We are looking select from list 1, and let us click on plot. Now let me change the color so that we can differentiate here. The color here, color, let us select blue on the plot. Now again let us duplicate plot, but let us select dt as 2 Kelvin, and you can clearly observe here. Let me change the color again to red. And what we can observe is, as I'm increasing dt, you can observe here all the red color. It is not almost plot, similar to where we made lambda as 0. Same thing happens as I'm going to increase my dt value. The flatness of the plot at 0 degrees Celsius reduces. You can observe it clearly here. You can compare these two graphs. That's what our conclusion. So dT, that is transition temperature, as well as lambda heat, have strong influence on the temperature profile and on x coordinate. Thank you for watching the video. Thank you.